Hello everyone. Dear student, in today's lecture we are going to see Dieckmann condensation reaction. Dieckmann condensation reaction, it is also called Dieckmann cyclization reaction. See, in Dieckmann cyclization reaction or a Dieckmann condensation reaction, a diester molecule, isn't it? What is a diester molecule like this? When we will react a diester molecule with a base like sodium ethoxide, then there will be a what? Intramolecular. Then there will be a what? Intramolecular Claisen condensation reaction will take place. Okay. Then there will be what? Intramolecular. Okay. See, this is what this is what a one molecule. Okay. But it is what? A diester. This molecule is what? Having a unit diester. So that means both the ester group are present within the molecule, isn't it? So there will be a what? Intramolecular Claisen condensation reaction will take place. So what we will have? We will get a product like, see here I will number it like this, so we will not confuse. 1, 2, 3, 4, 5, isn't it? Okay, I will have one more carbon atom here. Okay, we will have a one more carbon atom extra, so we can write ring properly. So we will get a product like this. Here what product we are getting? We are getting, see, this is what a alpha carbon, this is what a beta carbon. Okay, see, this is carbon number 1, this is carbon number 2. Okay, carbon number 2, isn't it? This is what a alpha carbon. Now this will be what? Carbon number 3, carbon number 4, carbon number 5, isn't it? So there will be what? Intramolecular Claisen condensation reaction will take place. Here intramolecular Claisen condensation reaction take place to get a cyclic, to get what? Cyclic beta, see, cyclic alpha beta keto, at beta position there is a keto group, cyclic beta keto ester. So Dieckmann cyclization or a Dieckmann condensation is a reaction of a diester molecule in the presence of base like sodium ethoxide or a strong base like sodium tertiary butoxide to get a cyclic beta keto ester molecule. To get what? Cyclic beta keto ester molecule. This is what? Dieckmann condensation reaction. Actually it is what? Actually it is what? Intramolecular Claisen condensation reaction. Actually it is what? Intramolecular Claisen condensation reaction. You know Claisen condensation reaction is what? A reaction of ester molecule, two ester molecule, two same ester molecule, isn't it? Which are having alpha hydrogen atom, which are having what? Alpha hydrogen atom to give a beta keto ester, to give what? Beta keto ester. That is what? Claisen condensation reaction. So it is what? Actual intramolecular Claisen condensation reaction. So what is the condition for this Dieckmann condensation reaction? A diester molecule should have alpha hydrogen atom. Diester molecule should have alpha hydrogen atom, otherwise this reaction will not take place, isn't it? Now see, we will see the mechanism for this reaction. We will see what? Mechanism for this reaction. See, in mechanism, first write diester molecule, isn't it? Then see which is a alpha hydrogen atom, which is a alpha carbon, that find out. Okay, this carbon atom is alpha and this carbon atom is also alpha, isn't it? Now we are having alpha hydrogen atom at this position, that I can show. So these two hydrogen atoms are alpha hydrogen atom and these two hydrogen atom are also alpha hydrogen atom. Now we will have a reaction of this diester molecule with sodium ethoxide. So sodium ethoxide will abstract any one of these alpha hydrogen atom, because both the ester group are same, isn't it? So it will abstract any one of these alpha hydrogen atom. So what we will have? We will have a carbanion. What we will have? A carbanion. So there is formation of carbanion. So this alpha hydrogen atom is abstracted by sodium ethoxide, isn't it, to form a carbanion. So that will have a counter ion sodium plus, Na plus. So now this carbanion will enolize, as there is what? Alpha carbonyl group. At this position there is what? A alpha carbonyl group, ester carbonyl. So we can have a resonating structure. We can write a enolate. This is what? Enolate anion, sorry, carbanion. For this carbanion we can write a enolate anion. For this carbanion we can write a enolate anion. So this is a enolate anion. Now in next step, this enolate anion will attack on the carbonyl carbon of second ester molecule which is present in the same molecule. Okay, so what you will have? You will have now, there will be a bond formation. Okay, this carbon, okay, this carbon will form bond with this carbon. There will be what? Bond formation of this carbon with this carbon, isn't it? It's not a oxygen, isn't it? It's not a oxygen, it's a carbon. That is, I am going to show how it will form a bond. See, right, this is what? Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. So you will have, see, when it will attack on this carbonyl carbon, there will be what? Shifting of this pi bonding electron density over this electronegative oxygen atom. So you will have isn't it? Show it like this. COET. So we will have such type of next intermediate structure. Now in this step, in next step, what will happen? This negative charge electron density will come here to form a carbonyl group, and at the same time this OET is what? A good living group that will get departed. So what you will have? You will have, see here, this is carbon number 1, 2, 3, 4, 5. Isn't it? So you will have this type of cyclic beta keto ester. Okay, this is alpha carbon, this is beta carbon. So this cyclic beta keto ester will form in a Dieckmann condensation reaction. This is what? Cyclic beta keto ester. So this is what the mechanism for this reaction, isn't it? See, as it is a what? sodium salt. Okay, so this reaction is we are carrying out in sodium ethoxide. Okay, there will be a one more step in, so sodium ethoxide will abstract this alpha hydrogen. Sodium ethoxide will abstract this alpha hydrogen, as reaction is in what? Sodium ethoxide medium. Okay, in alkoxide medium, in basic medium. So this alpha hydrogen atom is more acidic, so it will abstract this alkoxide ion, will abstract this alpha hydrogen atom, and we will have such type of intermediate now. Isn't it? Now it will get enolized like this, and you will have a next step, next intermediate structure like this. Isn't it? Now when we will react this compound with H plus, dilute H3O plus aqueous workup, okay, H plus or H3O plus, we will have actual beta keto ester here. So this beta keto ester will form, isn't it? So this is what? Cyclic beta keto ester. So this is what? A Dieckmann condensation reaction. See, in Dieckmann condensation reaction, once again I am repeating it, a diester molecule which is having alpha hydrogen atom, a diester molecule which is having what? At least one alpha hydrogen atom. Okay, when we will react such type of diester molecule with what? Sodium ethoxide, a base like sodium ethoxide, it will give a cyclic beta keto ester. It will give what? Cyclic beta keto ester. Now this cyclic beta keto ester, that is form, isn't it? So here you can write NOET in second H plus in presence of H plus, isn't it? So this is what? Second step. Last May we have to add for aqueous workup, that is dilute HCl. Now mechanism, in mechanism this is what? A diester molecule which is having alpha hydrogen atom. So alkoxide ion will abstract any one of these alpha hydrogen atom to get a carbanion. What is this? Carbanion. This carbanion will undergo tautomerization. Okay, sorry, we can say carbanion will undergo resonance stabilization, not tautomerization. Okay, so what is here? Resonance stabilization. So what we will get? Enolate anion. This is a enolate anion. To get a enolate anion. Now this enolate anion will attack on carbonyl carbon of second ester molecule. Okay. To get a this intermediate structure, cyclic structure. So here this new carbon carbon bond will form. Okay, this new carbon carbon bond will form, isn't it? So this new carbon carbon bond will form. Now this intermediate will push out, will knock out the leaving group OET minus, isn't it? So this OET minus will get pushed or knock out from this intermediate structure. Now this OET minus will abstract this alpha hydrogen, isn't it? This OET minus, isn't it? That will abstract this alpha hydrogen atom and to get a carbanion in this step also. Now this compound is what? A basic salt. It is what? A salt, in the form of salt. So we have to basic salt, we have to bring out in the form of neutral compound. So we have to react it with what? Dilute HCl to get a neutral compound, that is cyclic beta keto ester. So this is what? Dieckmann condensation reaction or Dieckmann cyclization reaction. Okay, I hope you have understood this topic very well. We will stop here. Okay, with the this Dickmann condensation reaction or Dickmann cyclization reaction, we can say that the topic, that is carboxylic acid and their derivative, is finished here. Okay, so we will stop here.